The volume V meters cubed of liquid in a container is given by the formula here, where h is the depth of the liquid. Find the value of dV/dH when h is 0.6, giving your answer correct, to 2 decimal places. Liquid is leaking from the container. It is observed that when the depth of the liquid is 0.6 meters, the depth is decreasing at a rate of 0.015 meters per hour. Find the rate at which the volume of liquid in the container is decreasing at the instant when the depth is 0.6. So I've got the question here then. So let's have a look at it then. First part, we need dV/dH, so we need to just differentiate with respect to h. This is a function of h. So part 1, so dV/dH, it's a function of a function rule. Something, first term is something to a power, so the power comes down, times something to the 1 less, which is a half, multiplied by the something differentiated with respect to h. Power rule, 6h to the 1, and that's a 0. And then the next term, minus constant goes to 0. So there's dV/dH, which equals 6 3s are 18, 18 over 2 is 9, times 3h squared. So 3h squared, 0.0, so it's 3 times 0.6 squared plus 4 to the half, square rooted in other words, and that's when h equals 0.6. So that's, I'm just going to put it here as well, equal to, so let's just type it in the calculator, 9 times square root of this stuff here, isn't it? 3 times 0.6 squared plus 4 equals, so it's 9 times 3 times 0.6 squared plus 4, 20.284. So it's 20.28, and that's the 2 decimal places. The volume, V meters cubed, of liquid in a container is given by V equals this formula here, where h is the depth, h meters is the depth of the liquid. Find the value of dV/dH when h is 0.6, giving your answer correct to 2 decimal places. Liquid is leaking from the container. It is observed that when the depth of the liquid is 0.6 meters, the depth is decreasing at a rate of 0.015 meters per hour. Find the rate at which the volume of the liquid in the container is decreasing at the instance when the depth is 0.6 meters. So here's the question in summary form then. So the first thing is dV/dH, so let's have a go at that. So here, dV/dH, then differentiating V with respect to the symbol h. This is a function of a function, something to the 3/2. So the power comes down, times the something to the 1 less, which is a half, multiplied by the something differentiated. And that differentiates to 6h plus 0. So it's just 6h. Next term, minus the constant differentiates to 0. So what does that equal then? 6 over 2 is 3, and 3 3s are 9. H times 3h squared plus 4 to the half, which equals, now put h is 0.6 in, 3 times 0.6 squared plus 4, square rooted all to the power half, which equals, so we need to type that into the calculator then. So it's 9 times 0.6 times square root of 3 times 0.6 squared plus 4. It's all in the square root bracket, equals, let me get 12.17. 12.17, and that was to 2 decimal places. So that's what we got there then. Now liquid is leaking out when the depth of the is 0.6, so part 2 then. We're told that h is equal to 0.6 meters. The depth is decreasing, so dH, the depth is decreasing at a rate, so it's dH dt is equal to, decreasing is a minus 0.015. Find the rate at which the volume is decreasing. So the volume dV dt is the rate of volume increasing, but it says the rate of volume decreasing, so we'll have to flip the sign. Okay, so equals, and don't forget that was, we need to do a minus to it, don't we? So dV dt first of all then. Well, dV dt is dV, we've got dV dH, so let's use the chain rule. dV dH times dH dt is equal to dV dH, which is 12.17, that number, times by the minus 0.015, which equals, so we've got that number still in the calculator here, so times that by 0.015, we know it's negative, 0.18, so it's minus 0.18, just check that again, and that's the 2 dp, isn't it, 182, so that's 2 decimal places. So rate of decrease, so answer, the rate of decrease in volume will be negative this, because this is the rate of increase, so the answer is 0.18. Volume is in meters cubed, and the rate is per hour, isn't it?